You guys hear me fine? Hey, Randy, how are you? I don't hear you, Randy. If I don't know if you're on mute or.
Sorry about
there
that.
You are.
Hey, George Spanos. Hi, nice to meet you. Say, have we met before? And tell us a bit about yourself.
Talking about me?
You, George Spanos.
Me? Oh dear.
Well, unless you don't want to, you don't have to. Absolutely don't have to.
No,
if you want to
I could totally do that.
Okay.
No, I'm a game technician. I work in amusements. I don't do the slot stuff like you.
Where are you from?
Initially, I'm from Crete, Illinois. I don't know if you could see my shirt. I'm actually wearing.
I'm wearing my. You know what I'm saying? Yeah.
Yeah, I'm wearing my old work shirt. Strictly coincidence. And
so you're a real route tech, job tech kind of guy. Okay.
Yeah.
My guy. Cool.
Yeah, I've been a fan of yours for a long time.
Oh, go on! You're embarrassing me. Go on.
Yeah.
Pleasure.
No, my Cree Family Fun Center, that was my grandparents' place. They're FEC.
No, I'm not unfamiliar with it. I'm not unfamiliar with it at all.
No, my grandpa used to give me his old Playmeter magazines, and I would like thumb through them, and I would get all the way to the very back where there was like the classifieds, and then I would see the ad for Randy Fromm's arcade schools, and like I was about like maybe 5 or 6 years old. I used to like nag them constantly. I'm like, I want to go to this, and
I had that prime advertising spot for decades. The first spot in the blue pages or whatever
I think they were yellow. Were
yellow.
They yellow?
No, I think they called them yellow pages, but they were blue. And
okay.
And I called them on that like a couple of times. It's like, why are you calling it the yellow pages? They're blue or whatever it was. Anyway, but anyway, thanks. Hey, and it's super nice to meet you. So, are you here now in your capacity as a professional game technician, or are you now sort of servicing or within the game collector community, as is James Crow? And hello, James Crow, by the way. George. James is from Toronto. Are you from Toronto?
Just north of Barrie, but yeah, about an hour and a half north of Toronto. Yeah. Is there anybody in the waiting room? I think John's trying to get in.
Oh, yes. Oh, I'm so sorry. Thank you.
No problem.
Thank you very much. Sorry, let me put my glasses on and see what the hell I'm doing here. I should make you the host. I think I will.
No, not today, because I'll be probably making a mess out of this, right?
Okay.
Maybe John, when John gets in.
Oh, it's Paul and so on. And John. Hey, how you guys? So, not to not talk to you anymore, George. I'm just saying hello to everybody. Yeah. So, hey, John. Oh, you're looking. It's duty now for the future. Look at him looking into the future. He's looking at the future of the world, John. Oh, that was very ethereal, sort of. That's the wrong word. Anyway, hey, nice to see you, John.
Nice to see you, Randy.
Are you in San Francisco? You're
no.
Okay. See how good I am at recognizing things. I can see that. I can see that that's the Bay Area. I think that's correct. Isn't that the Bay Bridge?
Yep.
The Oakland Bay Bridge. Okay. So, hey, Pete C. I don't know you, Pete C. Are you there, Pete C? No, he's not. Well, we don't care about Pete C. then anyway. What the heck? I have to admit more people. Gosh darn it. I thought I had figured out a way to not have to do that anymore. But but apparently you always have to do it. I just waiting. Why, Paul? Or why are you in the Paul? Why were
Okay,
you in the waiting room? There you are.
I'm hearing you now. This is PT. Thanks for letting me
Oh, hey, Pete. Hey,
lurk
hi.
here. And yeah, you do care about me, eventually, right? I'd like to think so.
Yeah, the lurk around you, lad.
Okay.
That's funny. When I read your name out loud, Pete C, it reminds me of Pete Seeger, a personal, not exactly a hero of mine, but if you know
Right.
who he is, banjo
Yep.
player, folk music, met him a couple of times. I come from a kind of a folk music background, and
Yep.
so not that you're Pete Seeger, because that's SEEG.
No, I'm more of a piano player than that. I'm not a folk singer either. Sorry.
And Brian Smith, I don't know. Have we met Brian? I'm not sure that we have.
No, Randy, I've just seen you on the forums on Facebook and whatnot.
Cool. Hey, welcome. Well, thanks a lot. You know, we're not really covering pinball in this,
Oh,
especially
yeah.
in this particular one, right?
Of course.
Oh, okay. All right. Cool. Well, hey everybody, and thanks for coming. I'm out of coffee. That's bad. Yeah. So if you guys can see, I guess you can see if somebody's in the waiting room. If you could let me know, and so I could let them in, that would be a good thing, I think.
I don't think we can see it so much as John just said, I'm in the waiting room and nobody wants to let me in.
Oh, I'm sorry, John. I don't like you that much. That's cool. Okay, so and this I'm especially directing this, I suppose, at Brian and Pete and George, since you're new to this sort of group. So we've done 8 of these so far. This is number 9, and the first 8 have been, pretty basic stuff. I mean, really, at least from my perspective, pretty. I don't want to sound demeaning, but low level stuff, easy to understand kind of stuff. But the question was raised about something that is, I would say, enormously more complicated, probably from your perspective. It isn't really. And I don't want to give you any kind of a mental block about like, oh, this is going to be so complicated, I'm not going to understand it. But the question was raised, and there's a couple of folks here who were prepared to discuss it about this particular issue. And so I thought we'd address it in this particular CRT workshop number 9. And that having been said, just for a second here, George or Brian or Pete, did you happen to come here with any specific question that you would like to have addressed by any chance?
Yeah.
So this is Pete. No, just really want to get a general, get kind of caught up here. I've been collecting mostly vids for a long time, and do my own cap kits and flyback placements and that, but nothing really beyond just basic shotgunning repairs. So figured this would be good to kind of sit in and listen to the experts talk here.
Oh, okay. And again, just to let you know, this might be, at least for the first part of this, a wee bit more complex.
Yep.
And Brian, are you cool with this? I mean, you
Yeah,
can
that's fine.
defend me.
That's about right where my knowledge base is at too. So
Okay.
I'm pretty familiar with cap kits and transformer flyback replacements, things like that.
Okay, groovy. And the hardware then.
Yes, sir.
You may not, Brian, I'm talking to you. You may not be totally cognizant of the theory of operation of things, but you're familiar with the hardware.
Yes.
Awesome. And George, are you more or less in the same boat, or what's your deal?
I've done all kinds.
Okay.
Yeah.
Would you consider yourself an intermediate or maybe even a little more advanced sort of tech?
Probably advanced.
Oh, good. Go. Great. So,
Yeah.
George, feel free to jump in. If you think that I have failed to say something or I've said something incorrect, put your neck out on the line there and say, "Hey, Randy, are you sure about that?" And I'll either back it up or I'll say, "Ooh, I misspoke," or no egos here, right? So if it's all good. All right. So any other comments before I sort of get going on a topic that I guess John and Paul and I. Where is Paul? Paul, what happened?
Right here. Hey, Randy.
Oh, okay. Hi. What we've discussed. Is everybody cool, ready to go, or did you have some kind of comment or something before we get going? Anybody?
Yeah, I'm by no means an expert, so I'm here just learning like everybody else, and we'll see what I can do.
Is this Pete speaking?
James, sorry.
Yeah.
Oh. Oh, wow. I don't even see you up here on the board.
It's because I got you on my external camera. I'm showing you just the front of the monitor with the retrace lines that we talked about there.
Oh, dig. Okay. All right. All right. So,
What model was the monitor?
Sorry?
it's a
What model was the
K4600.
No, it's a 20 C EC.
I'm sorry.
Easy.
Go ahead.
Sanyo. It's inverted.
Yeah.
It's
Sorry.
inverted.
My bad. So it doesn't matter what it is. So I am now sharing my screen. Is everybody seeing my screen?
Yep.
Cool.
Gotcha.
So that's a great feature of Zoom. I really like this. I'm really, as I've mentioned a few times, I'm really just kind of figuring this out. So here we go. So the issue, if you look at James Crow's image here, let me stop sharing it. I think I have to stop sharing it so you guys can see it, right?
I think if I speak, then it'll show up probably on the full screen.
Speak then.
Okay, so if I'll just continuously talk here so you see the image there. The retrace lines don't go away when you try and adjust the flyback. They are just constantly there, and any adjustment in any brightness or whatever doesn't do it. They're constant. They're always there, all white. Is that all the information I think you need, right?
I think that's everything you need. Everybody perceive that now?
Yep.
Okay.
Yeah.
Groovy. All right. So let me share the screen again and let's talk about this a little bit. So the issue here, as far as I can tell, is in something known as blanking. And in fact, now that I think about it, let me just go to the board here. Give me one sec. I gotta figure out how all this works. Stand by. I gotta stop sharing the screen, I think. And stand by, everybody. And I need to go to XSplit. Sorry, stand by. I'm honest to goodness, I don't even look at this when I'm not doing these classes. And I'm not exactly a Luddite, but this is something I'm still getting used to how all this works. So stand by. Oh, for goodness sake, you silly thing. There we go. Okay. And switching to that. Yay. All right.
Quickly, Randy, did you want to pass to John or something like that the ability to let people in?
Yeah. Yeah. Are there people waiting, do you think, right now?
I can monitor that if you want, Randy.
Yeah. Okay. Let me see how I can make you host. I'm sorry for everybody else. Just hang on. Again, I'm just.
These things are going very well. You seem frustrated for some reason, but don't be. You do well with these.
Okay. Well, thanks.
Yeah.
Yeah, I do want to make John the host because I love John. Okay. And he's attractive and he got a haircut and everything. So that's pretty cool. All right. So is there anybody waiting now? I don't
see anybody at the moment.
All right, groovy. All right, so you're looking at now at the whiteboard, correct? Everybody okay? Here we go. So I'm just going to hop on the whiteboard for just a sec, and then we're going to go back to the schematic diagram and take a look at that. So just to reiterate the basic theory of operation of how it actually draws the picture, I'm not going to spend any real time on this. So here's the actual CRT itself. And as you know, the beam or the beams begin in the upper left-hand corner when they first appear. And the line is drawn from left to right. And, it's really just the beams moving across the screen, but we see a line as it goes. At the right-hand edge of the screen, there is some sort of a sync pulse. It may be a positive going sync pulse like that. It may be a negative going sync pulse like that. It doesn't matter. Either the sync pulse starts at 0 volts and jumps up to 5 volts, or it starts at 5 volts and jumps down to 0 volts. It doesn't matter. It's a synchronization pulse. And when the monitor receives that, as you know, it causes the beams to turn off and quickly move back to the left-hand side of the screen. As you know, it only draws one line at a time on the screen, and it only draws them from left to right. It takes approximately 50 millionths of a second, 50 microseconds, for the beam to move from the left-hand side of the screen to the right-hand side of the screen. But when it returns quickly back to the left-hand side, when it fly back, get it, from the right-hand side back to the left-hand side, it does that really fast. It flies back in only approximately 13 microseconds. Since it's not drawing a line on the way back, it doesn't have to do it slowly. It can do it really quickly, but the beams are really turned off during that time. It's the magnetic field that is resetting, but the beam itself is supposed to be turned off during this time period when the beam moves from the right-hand side back to the left-hand side, which is known as the retrace time. And in this case, it's known as the horizontal retrace, as you know. It's called the horizontal retrace time, and that's this 13 microsecond period when it's at the right-hand edge and it's done drawing that line of video, as we call it. It's one raster line, but it has video in it, so it's a line of video, and it returns back to the left-hand side, blah, 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 blah. So we draw 240 of those lines in sort of a standard resolution golden era video game sort of a thing. We draw approximately 240 lines. And now the beam is at the bottom edge of the screen. And since it can't go any further down, obviously, now it's time to get what we call the vertical retrace. Right, exactly. Whoever just said that. So that's the vertical retrace. And this is really important. And that beam brings the beam from the bottom of the screen back up to the top of the screen. However, and this is really critical to know, the vertical circuit is really slow. The frequency of the vertical circuit is only 60 hertz approximately, pretty much, in a standard kind of a video game. So it's very, very slow. Same frequency as our AC power in United States of America, right? 60 hertz. But the monitor, as you know, does not depend on that AC power to get that 60 hertz. Yes, it is the same frequency. No, it's not a coincidence. But that frequency, that 60 hertz, is developed internally inside the monitor by a circuit that we might probably look at sometime in the future called the vertical oscillator. There it is. But yeah, and if we're getting more advanced, please relax. I'm not going to go into that now. In the future, we will. It's actually pretty simple and fun, but we'll talk about that later. Anyway, so it does happen to be the same frequency. However, the horizontal frequency is much faster, as you can imagine. Just think about this for a second. Just put your brain in gear don't just listen to my words. Put your brain in gear for just 1 second and think about it. If the horizontal circuit has to make 240 lines, while the vertical just goes from the top to the bottom once, making one complete screen full of lines, which we refer to as a field. One complete pass of the beam from the top to the bottom of the screen is called a field. If the horizontal has to go 240 or so lines times back and forth, while the field just goes once, obviously the horizontal circuit is working at a much higher frequency, and it is. The horizontal frequency is typically around 15,750 hertz, 15 kilohertz. Now, really technically, if you were really just to be absolutely correct, if you're interested in more advanced jazz, and you may not be, and that's fine. If we were talking about standard, what is known as NTSC video, which is the standard video standard that we use in North America, used to use in North America. It happens to stand for, you don't need to know this, National Television Standards Committee. It's just a standard that we use for video. The actual NTSC standard for horizontal is actually 15,000. Oh my God, brain fart.
That's 748 or something.
Oh my gosh. Yeah. Wow. Total brain fart. Sorry. And the vertical is 59.92 hertz, actually. 50, 34. 734 hertz. Sorry. Wow, that was pretty weird. 15,734 hertz to be really, because the division works properly that way, but we don't really care. You just don't care about that. My point is this. I'm sorry. So just give me a step back for just a second here. So the horizontal is moving really fast compared to the vertical. Well, during this vertical retrace time period, where the beam is at the bottom of the screen and has to move back up to the top of the screen, it takes a while for that to happen. It takes 1.3 milliseconds or something like that for that to happen. It takes 14 milliseconds for the whole screen, the whole field, and about 1.3 or something to bring it back up. Anyway, by the time that happens, here's my actual point. Sorry to digress, that the beam has actually moved back and forth. This is the big key, a bunch of times like this, about a dozen times. This is really important. You are seeing the beam on its way back up here. You are seeing, normally it goes down like this. As the horizontal is going back and forth, the vertical is pushing it down and putting one line underneath the previous line. But these diagonal lines, they're called vertical retrace lines. They are not vertical lines. They're not vertical lines like that. They're called vertical retrace lines because they happen during this vertical retrace time period when the beam is at the bottom of the screen and it has to come back up to the top of the screen. But that's real slow because it's vertical and it's a slow poke. But the horizontal goes back and forth a few times. So the image that Paul has shown us is that you see the good raster, you see the game playing, but it's all washed out. And you also see these vertical retrace lines, which are when the beam is coming back up. Well, we're not supposed to see those lines. Here's the big deal. We're not supposed to see those lines because there is a circuit known as the blanking circuit. It's called blanking. And it is way not an unusual, it is way not a usual failure. It is a very unusual failure to find blanking issues because it doesn't work very hard. The blanking circuit doesn't work very hard at all. And in a monitor, the things that work the hardest are the things that fail the most. And I think that's true of life in general, right? So we have an issue, and this is what we're discussing right now, with what I think is a blanking issue. There's sort of another related sort of thing to blanking. And again, this is more advanced, everybody. And if you don't get this, we're recording this, so you can watch this again and again and again. There is another sort of part of the blanking circuit that some monitors have, not all of them, and it's known as the beam limiter. It's called the beam limiter. And by beam, we're talking about the electron beam that comes out of the cathode ray tube that strikes the front of the picture tube, the beam, or beams really, because there are actually three. Well, the beam limiter in some monitors can be a really important circuit because if your beam current, I'm not talking about voltage here, this is very important. If the beam current is too high, you will burn out the phosphors. And you can see when the beam current is too high, you get that, what some people refer to as the blooming, sort of. That is to say, the image, instead of being crisp little raster lines is all fuzzy and super bright and like that. That's when the beam current is too high. And you can wipe out the electron gun itself, and you can wipe out the phosphors that coat the inside of the front of the glass of the CRT that the beam is hitting. So anyway, so there's a circuit called beam limiter. So whatever your problem is, I am guessing this problem that we've been shown. It's not exactly a wild ass guess. It's an educated guess. I am guessing that we have an issue with blanking or beam limiting because it seems to be completely washed out. So what I think is happening here is, and I could be wrong, I absolutely could be wrong. The monitor draws a line from left to right, but I think that we are also seeing the horizontal retrace line as it comes back from the right back to the left in between each of the raster lines that we are supposed to be seeing. And it's pretty obvious, it's completely obvious that we are seeing the vertical retrace lines that always look like this, the sloping from lower left to upper right in a normally oriented monitor. And you see, if you look real carefully, typically you can see sort of a little kind of a dimmer line on the way back. That's the horizontal retrace line. And then you see the vertical retrace line, you see the horizontal retrace line, and like that. And so that's the issue that we're going to attack now. And Paul, you have done a cap
Not me.
kit. Or who is it? John? Is it yours? Whose is it?
James.
No, it's mine.
Oh, James. I'm sorry. Forgive
That's
me.
not a problem.
I love you all, right? So,
Yes.
anyway, so you've done a cap kit, but those are just standard electrolytics, and you have not necessarily replaced every single electrolytic capacitor in the monitor.
No, that's right. Just with your
Okay.
standard cap kit is
All right.
all completed to date.
So with that in mind, let me have a seat and let's take a look at the schematic diagram. And what one of the things that I kind of want to get across to everybody. Hey, Brian, thanks for sticking with me, and everybody. I really appreciate it. I mean, you're wearing this pinball shirt, so it's kind of like, well, I'm not doing pinball, but all right, stand by. What am I doing here?
I'm just interested in learning anything about
Awesome.
the
Awesome.
CRTs.
Well, that's great. That's great. All right. And what am I doing here? Okay, share screen. Here we go. So James, this is the schematic of the thing that we're talking about, correct?
Yeah, and matches the schematic I have up here. So.
Okay. And so here, and again, I want these things to be educational. It's not so much we're trying to fix this one specific monitor. Let's take a look at the circuit and how it works. And so here's the deal. So this is obviously the neck board, the CRT socket assembly, the neck board of the thing. And you see the green, red, and blue video output transistors. And of course, those are the things that control the cathodes. And remember that the cathode, the lower the voltage is on the cathode, the more the gun emits. We've talked about that previously. I'm not going to go over it again. Look at some other workshop and you can figure it out. So the cathodes are attached to the video output transistor, and these are always like NPN well, they're always NPN. And basically it's what's known as a common emitter amplifier. That is, the emitter of this thing is more or less grounded, not exactly, but pretty much more or less. So whatever we're looking at here, the blanking circuit, sorry, let me back up. The first thing we want to figure out is where the hell is the blanking circuit? They may not be labeled. The transistors themselves may or may not be labeled. Is there some way that I can figure out? Because let's say I don't know anything about electronics. I'm just a parts changer, which, by the way, I am. I mean, I know something about electronics, but by and large, I just change parts until the problem goes away. So if you're doing that too, I'm okay with that. I really am. So anyway, so So what we're looking for is, how can I figure out where the blanking circuit is? What is common to all three outputs? This is the key to the thing. I'm looking for something that is common to all three of the outputs, red, green, and blue, because during the blanking period, during the retrace time, when we have to blank the thing, we need to control all three guns simultaneously. So what do I see that's common? And one of the things I see that's common is right here. If you look at this, you see how this green output right here is connected to 5600 ohm resistor to this wire. Oh, and so is the red output, 5600 ohms. And so is the blue output. Gee whiz, are those not common to each other? Yes, they are. But that's not the blanking circuit. That is the power to the DC voltage, the power supply to the output circuit. So let me just hop back to the board for just a second and just real quickly explain what the deal is there and how this is not what we're looking for. This is absolutely not what we're looking for. This is common to all monitors. They're all built more or less this way.
I think you have to stop sharing your screen, Randy, so your
sorry.
your image
Sorry.
will pop up.
Sorry. Thank you very much. Thank you. Yes, yes.
Yep.
All right. Thank you. Thank you, my stage manager, whoever you are. Is that James? Who are you?
Yes, it is. Sir.
Okay, thank you. Okay, so, and again, this is just by quick way of review, and if you've never seen this before, this is kind of what is the way it works. So here's the picture tube itself, and I'll just draw one cathode there. So that is the thing that makes the electrons come off. We call that the cathode. That's part of the electron gun. Physically, it actually looks like a little cylinder like that, but it boils off the electrons, and we don't really care more about it than that. But this is connected to the video output transistor. This is what's called the video output transistor, and that is one of the three, typically just three transistors that are on the neck board of a monitor. So these are always NPN transistors, always NPN transistors. I'm simplifying the circuit quite a bit. The emitter, as it's called, is grounded to a chassis ground, to the ground. Here's the important part. Each one of the collectors is always connected to a fairly high wattage resistor. Typically, it's like a 2-watt resistor. Its actual value may vary. I think, what do we look at here? 4,700, right? 4.7.
5,600.
Oh, is it 5,600? Sorry. So 5.6K. It's usually around that. It doesn't matter, though, for our discussion. And this goes to what's known as the video B+. The video B+, typically, not always, in the K7000, this is not true, but the video B+ is typically a separate power supply that is somewhat higher in voltage than the power supply that's used to drive the majority of the other circuitry, like the horizontal output circuit and stuff like that. And if that didn't make any sense to you, please don't worry about it. You know, typically it's somewhere around 125 volts DC. It can vary. Doesn't matter for the sake of this discussion. So there are three of these exact same circuits. So those things that I just pointed out to you on the schematic is not the blanking that we're looking for. It is how the power is connected to each of the cathodes. And remember that this is not part of our discussion, but just to recall, for those of you that or maybe have never seen it before, when this transistor is turned on, it lowers the voltage on the cathode. And the lower that voltage is, the more that gun turns on. That's not the point of our discussion, and I won't go any further. So that's not what we're looking for. Let's see if we can figure out where the actual blanking / beam limiter thing comes in. So let's take a look at that. And okay, so that thing I just showed you is this. These are the video output transistors. There's the 5600 ohm resistor that's connected to that has to be the video P plus. So that's not it. So Gosha Rudy, what else can we see that's common? Oh, right here. Look at the emitter of each of these transistors. The lead with the arrow on it, as you recall, is called the emitter. And each of these is connected through a potentiometer that adjusts what's known as the drive, the sort of amount of amplification of each of the colors. And they're all connected together. Bonus. So that's what we're looking for there. Now, remember the way a transistor works, and I'm not going to get into heavy transistor theory here. We could do that at some other date. But a transistor like this just requires 7/10 of a volt on the base to turn it on. 0.7, 3/4 of a volt or so, 0.7 turns on the transistor. But, and listen to me carefully, this is important. The transistor base, this is the base, the controlling element, compares itself to the emitter, which is this lead. To turn on this transistor, the base has to be 7/10 of a volt higher in voltage, a higher voltage, 0.7, than the emitter. My point is this, that here we clearly see the red, green, and blue signals coming from the preamplifier. You can see it red drive, blue drive, et cetera, et cetera. So that's obviously the input, and it goes into the base, which is really obvious. But we can modulate the emitter, modulate, M-O-D-U-L-A-T-E. We can modulate the emitter. That is to say, if we change the voltage on the emitter, that also turns the transistor on or off. It's only the difference in voltage between the base and the emitter that controls the transistor, not what the actual voltage is. It just cares about the difference between the two. So you'll notice that all the emitters are tied together here through these very low ohm resistors, 200 ohm potentiometers. Gee willikers, where are they connected? So let's see. And so all of these three connections come here, and oh my goodness, there's a service switch, which is very unique to this particular monitor, although it was common in older consumer monitors. And this switch, which you could see is either in the normal or service position, let's just look at the normal for now. Let's forget about the other position. So these are all the emitters, and they are connected through this switch, which certainly can be bad. When you have a switch that's not been operated for 30 years, it's going to be corroded inside, and very often just switching it back and forth a dozen times cleans it up, but it certainly could be bad. And here's the deal. Watch this carefully. This guy goes to the emitter of a PNP transistor. You can hardly tell, but the arrow goes in here in the center. Let me see if I can make this bigger. Hang on a sec. I'm a genius. Okay, so let me just scroll down here. Hang on. Okay, so here's a PNP transistor, which is connected from all those emitters to ground. Well, that's the blanking, isn't it? Blanking or beam limiting. If that transistor is turned on or off, it's going to control the voltage on the emitter and make all three of those transistors do one thing or the other. And I don't know, Paul, Paul, this is your monitor, right, Paul?
No.
Oh, whose is this? I'm sorry.
James.
James, I'm sorry, James. God,
No
forgive
problem.
me. PNP transistors are far less reliable than NPN. James, have you tested or replaced this transistor?
I want to say we tested it, but now you make me uncomfortable to say I know for sure it's not.
Okay, well that's
Or
fine,
good.
and we're going to want to toss a new one in there for reasons that I personally don't know my own self. It has to do with manufacturing processes, as we would say in Canada. The PNP transistors are less reliable. So that transistor is what's known as a ground switch, and it will ground that line right out when it's turned on. What turns it on? Gee whiz, let's take a look. So over here, there's another transistor here that turns it on. Let me scroll up here and let's see what's going on here. Oh, DC level control. Level control, sub brightness. Oh, gee whiz. All of that sounds like it could have something to do with whatever the hell our problem is, right? I mean, it could. So, as just a technician, this is a 5-cent part, a 15-cent part. I'm not going to agonize over this thing. I'm going to pull this part out and just stick in a new one. Because even if I pull it out and test it with a digital multimeter or some other transistor tester, that might be 99% accurate. But what if I could just throw in a new one and make it 100% accurate? So that's a real common transistor. You could use a 2N4403 or a 2N3906 or something like that. That's a super common part. And it's operating at low frequencies and, so like that. But here's the deal. We have an oscilloscope here. So let's take a real look at what the heck we're looking at. Is everybody cool so far? Let me just stop for a second. Everybody okay? Let me just wait. Let me change camera and give you the full
Good here.
benefit of my
Yeah.
face. All right. So,
Randy?
is everybody with me so far, or are there questions so far?
Randy,
Yes.
I think we're on the right track here. I don't know if you remember, but a few weeks ago, I had this exact same problem on a Sanyo EZ, and I pretty much shotgunned this whole circuit, and that fixed the problem right there.
But you never verified which component was actually at fault?
I got tired of just swapping out one component at a time, so I just did the whole circuit. Basically, what mine was doing.
I don't blame you. Let me interrupt you. Sorry, I will. I'm sorry, because it's my show, right?
Sure.
There's nothing wrong with doing that. It's especially if you're tired, you just want to get the thing working, and that's the bottom line. And your success rate is great, and I absolutely can't argue with that. I'm just always dying of curiosity as to which part is the one, as you know.
Mm-hmm.
Sorry, Paul. Go ahead. So
Sure. My issue was the picture would look great, then a minute later it would go back to raster lines, and I was just probing on the diodes and the transistors, and every time I go back to the raster lines, it would fluctuate the voltages on that line. So I just basically, and then when it went to raster lines, you couldn't control the sub brightness. The sub brightness would do nothing. So I just shotgunned that whole circuit, and that fixed it. Just plain and simple, just like that.
That's super. I'm proud of you, boy. I mean, that's really great as far as I'm concerned. That's the bottom line. But I'm just a nutcase about electronics.
Mm-hmm.
I mean, I don't expect any of you guys to be as weird about this stuff as I am. I just love electronics. I love everything about how it works and all that kind of. Hey, Andrew, how are you?
I'm doing okay. Sorry, I'm late. I was
No,
off with my daughter doing fun things.
It's all good. Hey, Pete Cahill, Pete C. Oh, you're Pete C, but you're Pete Cahill. I see.
Oh, I had to fix that. That was from my previous Zoom, so I thought I would come clean here.
Are you related to Tom Cahill by any chance?
No.
Oh, Tom Cahill was the head of service for Williams Pinball.
Okay, no.
Okay, so if you're ready, James, to do this probing, what monitor do you have fired up, the bad one or the good one?
I actually have both fired up at the same time.
Okay, so here's what I'd like to look at, if you don't mind. So everybody, just to let you know what we're planning, James and I have worked this out ahead of time. He has two identical monitors, and I think it would be a great idea if we looked first at the good one. I think it's a great idea to look at that. And since we have the advantage of A-B comparison. So let's take a look at transistor 302, TR302, which is this guy right here. Obviously, we don't care about the collector. It's grounded. No care about that. So let's take a look at the emitter of this thing, which would be the far left-hand leg as you're looking at it from the front where the flat part is. And can we look at that, Paul? And then I guess I have to stop sharing, I think, and you have to share I guess we have to look at everybody. Look at James. Look at James. I'm not
I
sure
have to
how to.
speak, I think, and then it'll pop up.
God, there has to be a way to actually invoke you as full screen somehow.
If people double click on his image, it'll pull him in as the focus.
I tried that. It's not working for me, but maybe because I'm host.
Probably.
Doesn't work for me.
So it's a little tight to get in there, but I can.
Yeah, and we just want to look at the graticule. We don't need to look at your knobs. We just want to look at the screen.
Okay. And sorry, what leg were you saying of TR302?
Yeah, and the the collector is grounded, so obviously that's 0. But let's look at the emitter. We could look at the base as well. Let's look at the emitter and the base. But we need to see it a lot closer and a lot bigger. Oh, there we go. Oh, there we
I can
go.
see it pretty good.
Yeah. So increase the amplitude, make the vertical divisions, the volts per division smaller so that it synchronizes. The way the scope works is if the amplitude, the height is not big enough, it won't sync on it.
Just checking. Can everybody see James' screen large now?
Yeah, I can. Beautiful. How did you
Okay.
do that?
I
As soon as he
I-
moves his hand.
I right clicked and spotlighted on him.
Oh, okay. Okay, thanks.
Let me know when I'm
So you want to synchronize on channel B or 2 or wherever the sync is coming in there, whatever that signal's coming in. I don't know why you have 2 channels open there. Just one is all we need. There you go. Awesome. So that is a awesome. Oh, what happened there?
It turned off for some reason on this one here.
By the way, if any of you are really interested in moving on, oscilloscopes now are a lot less expensive than they used to be. A lot less expensive. For a few $100, you can get a decent scope.
I
You're
think
still
this
not
one.
looking at. You want to look at positive slope to trigger, and you want to look at whatever vertical channel you have going in there, whether it's 1 or 2 or A or B. I don't know.
Yeah,
What
give
you
me a
have
second,
to
'cause
think
I gotta
about.
hold the probe against the piece. So I'm gonna put on
And
the other
then-
piece that lets me hook on.
Oh,
it.
you don't have a little hooky thing that you can just hook on?
I do now. I do now. I was gonna flip it around here. Okay.
Hey, yay! Close enough. Whoops.
Hold on a second.
What the what? Yo, bro.
I can buy the toys. Doesn't mean I know how to use them, right?
Oh, right. Well, this is using a scope is super fun and interesting, and it takes a while to really get into it. But once you have it, it's fine. So you can make it just to look at the vertical pulses if you want. It doesn't matter. That's a nice, easy one to see because it's only 60 hertz. So you can slow it way down and use. I mean, you had it before there.
I did.
And what are we looking at there? The emitter?
Yes.
Okay. You got to get it up, bro. So I think what we're looking at there is the horizontal pulses serrated by the vertical pulse. So your time base is correct. You just need the amplitude to be higher. The vertical, make the volts per division. And doesn't the scope have an auto button? Can't you just press one button that says auto?
Yeah, that's what I'm doing. For
There
some
we
reason,
go. Okay.
It
Up.
does this like this though.
Okay, that's fine. Whoa.
I'm not sure why it's
Oh, okay.
autoing like
So
that.
so if you want to see the horizontal pulses, take the time base per division, the sweep, the horizontal sweep, and crank it to the right. See them? See all the pulses there? That's what
Yeah.
it's synchronizing on. And make the amplitude higher. Make the volts per division, 0.5 or 1 volt per division or something.
It goes out of the screen every time.
Oh, put it on. Oh, really? Put it on
Yeah.
AC. Oh, do you know how to do AC coupling? You probably don't.
Not on this one.
All right. Okay, never mind. All right, so let's now move over to the bad monitor. We can see clearly that there are some pulses there. I'm talking to everybody, everyone that's listening. So clearly there are pulses there. Let's see if they still exist on the other monitor. Ideally, what it would have been nice to do is set up the scope so you saw the perfect pulses and just move the probe to the other monitor. But we didn't have that. Is this the same? We're looking at the same place?
Yeah, this is the emitter on TR3, or the emitter on TR302.
Can you change the volts per division and make it a 1 volt per division?
That's 100. That's
Can't you
100
just
per
adjust
division.
vertical position and bring it back down again?
Yep. It just keeps jumping way up out of the screen.
It's gone.
Yeah. What's going on?
Well, this isn't helping us, bro.
Oh.
Oh, that's too bad. If
It was
we
working
could,
earlier.
if we could have pulled this off, yeah, that doesn't look like anything like the good one, does it?
No.
It really. Okay, so let me share my screen again here. Stand by. Okay, so you are now looking at this point right here, correct? And we're seeing something completely different. So the question you have to ask yourself as a technician is, could it be this transistor, which I highly suspect because it's PNP? Could it be this transistor, which clearly, even if you don't know nothing about electronics, it's clearly hooked up right to this one, that the output of this thingy, even if you don't know anything about how this works, it clearly goes into this thingy. So if this thingy is bad or not, maybe this thingy is bad. And then there's a potentiometer between these guys here, which we don't care about to discuss right now. So my point is this, and I guess let me just change my input. Stand by. Okay. And look at me. Everybody look at me. Everybody look at me. How do you look at me? Oh, and there's you. I don't want to look at you, George. Everybody look at me. Everybody look at me. I don't know how this works. Anyway. Yes, go ahead, George. Yeah, go ahead.
What about that diode?
Let's look at it. It's not a common failure, certainly. This diode right here that goes between the emitter and the base. So that's just what's known as a clamping diode. It is only to prevent reverse polarity there. It would have to, if it was shorted, we'd get nothing at all. Oh, you're right, George. Yes, if it was shorted, we'd get no blanking at all, wouldn't we? So that would certainly, you're absolutely correct. Absolutely correct. I would definitely test that.
Doesn't the waveform look like it's like inverted compared to the good one?
It does. And it looks like it's also has some weird DC bias, which is bringing it way up high, which to me means typically a semiconductor failure, although it could be a leaky capacitor. But leaky capacitors, as you know, are not as common as capacitors with high ESR. So it certainly could be this C303, but I think you've probably replaced that one, I'm guessing. Have you, James? Has that been replaced?
Sorry, which capacitor was it?
C303. Do you see this on the screen right now?
C303. Yeah, I believe that one was replaced, yes.
I imagine it was. But George is correct, and I absolutely would definitely look at that. And it should be obvious when you throw a meter on it. But I can't imagine what else it would actually be, unless it's something weird like a bad pot, which I don't believe it would be.
The diode 303 I did check, and I believe it functions fine.
Yeah. You're looking at a tiny amount of leakage possibly, though. On these older, I would never say this previously, but on these older semiconductors, weird things are starting to happen. So, I wouldn't discount anything. To be honest. Okay. So, I mean, does that make sense so far? Everybody okay with this so far?
Mm-hmm. Sure. Yep.
Yeah. I see James now.
Yeah,
that looks really sloppy. What the hell?
That's on the my analog scope. That's the same leg off TR302.
It would be better if you synchronized on, for example, vertical sync or something, because what you're seeing is several traces writing over each other.
Right.
As you can see, you don't really see a clear waveform. But you know what? Maybe that might be a really fun and interesting workshop to do, an oscilloscope workshop, maybe.
I would be interested in that. You used to have a great video on your actually on this exact same model, the Tektronix
2235. Yeah. I did take that stuff down just because I don't know why. Because I'm doing this new thing with the workshops, I guess, and I don't know. I don't know, but I think that's beyond the scope of what we want to cover in this particular workshop. So anyway, so that's what I think your next step is, to pull all those parts out that we just looked at, the beam limiter, blanking circuit, and replace that PNP transistor and see if the problem goes away. And like Paul said, he changed all those parts and the problem did go away. So I would be very surprised if it didn't. I do have, if you're interested in learning more about blanking, I do have one more little bit of lecture on the blanking circuit in the G07 that's kind of interesting, if you'd be interested in seeing that.
Absolutely. I got a few
Yes.
questions about that G07 as well, because I've had similar problems with the G07s over the past few years.
Okay,
With,
who was that
same
was just speaking
problem.
there? Is that Pete?
It's
Who was
Paul.
that? Oh, Paul. Oh, okay.
Um,
Okay.
Although this is Pete, and yeah, I've seen retrace problems a lot in Geo7s, and again, I just shotgun the whole thing until it goes away. So I'd love to know more about it.
Oh, okay. This is really simple to understand and quite educational. So stand by while I pull up the schematic here.
A major thing I've seen in the Geo7s with retrace lines is broken traces on the flyback going up to the neck board. The neck board is supposed to get about 170, 180 volts from the flyback. And if there's a broken trace or a diode 503 is shorted, you'll get those retrace lines even if you turn the flyback all the way down.
Yes, and again, that comes down to low voltage makes high brightness. So that when your video B plus, which is what you're talking about right there, fails, it turns on all three guns like totally all the way. And so that's certainly something you always want to check. That's for sure. Okay, so I'm just pulling up the schematic standby here. I actually have an illustration about this in my in that blue book that I have, but it'd be just as easy to do it this way. So stand by. We'll look at the actual thingy here. Oh gosh, they're so confusing. Ah, there we go. Okay. So, can everybody see the schematic?
Yep.
All right. So once again, what we're looking for here is, let's say we don't know anything about this monitor. We've never seen this monitor before, got no idea, but I want to look at the blanking circuit. So I see obviously the neck board, the RGB video output printed circuit board. You see the actual CRT itself, and should always be in the right-hand side because it's an output. And on a schematic, outputs are on the right and inputs are on the left, as you know. So, sorry. Here are the three video output transistors. And once again, you do see this common deal where we have like a pretty big resistor, 2 watts. In this case, it's 10K. If you recall, it was 5,600 ohms before. And they're all three connected together, and they go to this thing, which is called the video B plus, and that's the 170 volts or something that was being referred to earlier. So that's not our issue. They're all like that. That's not blanking. That's just the power that goes to the output circuitry. But when you look at the bases of the transistors, remember the base is the input. The base is the controlling input of a transistor. And remember that the difference in voltage between the base and the base emitter, is what turns the transistor on, and it has to be 0.7 of a volt higher on the base and the emitter, because this is an NPN transistor, right? So anyway, so all three of these bases are connected together, and this makes a type of a circuit known, and I'll put this on the board in just one second. It's known as a common base amplifier. We're used to common emitter amplifiers, but this is a common base amplifier. And forgive me again if I'm getting a little more advanced for some of you folks, but here we go. So all three of these bases are connected together. Gee whiz, where does this base signal come from? Not where does it go to, right? Where does it come from? So let's follow this wire where all three are common, and we follow it over to the left. And gosh, Rudy, there are our buddies, the beam limiter and the blanking, just as we discussed previously. And these are transistors that are ground switch configurations. That is to say, when this transistor turns on, X303, let's say, this here wire up here on the top is going to be connected to ground. When X304, the blanking transistor, turns on, this here wire right here is going to be connected to ground. So it's known as a ground switch. Let me switch to the big board here. Hang on. So I guess I shouldn't flex on my enormous musical skills, and we'll just do that instead. There we go. All right. Cool. Is everyone still with me? Everybody okay? Everybody cool?
Yes, sir.
All right.
Yep.
All right.
You need to
So we're
stop sharing the image first.
Oh, sorry. Thank you. Thank you. Thank you. I'm glad one of us is aware.
There we go. That's it.
Look at me. Everybody look at me. We're just looking at James now. Why can't we look at me? Look at me.
I'm seeing your whiteboard.
Oh, are you? Okay. All right. Good.
I don't know about anybody else, but I'm seeing it. So
All right. That's all that matters. As long as
exactly.
you are happy, then I'm happy. All right.
Okay, now I'm looking at oscilloscopes again.
All right. So anyway, so we have the three cathodes, 1, 2, 3, that are in the neck of the CRT, and of course they are connected to the always NPN transistor. And again, I'm simplifying the heck out of it here. The emitter is sort of grounded, basically. It's, as far as we're concerned, for the sake of this discussion, it is. So these are the three video output transistors, and all their bases are connected together. Oops, cathode, right? So all three of the bases are connected together, and then they are connected to these two transistors, and one is an NPN transistor, that's the blanking transistor, and the other, which the operation of which is a little more complicated, and I'm just really not going to go into it right now, is the PNP transistor, which is the beam limiter. And we don't really care about that, but clearly you can see that when these transistors are turned on, and remember, when a transistor turns on, the collector, this lead right here, is connected to the emitter, which is grounded in this case. Again, it's known as a ground switch. So this thing, whoa, oh my God, hang on, stand by. That was pretty bad.
You guys having another earthquake out there?
Yeah, right. So the blanking transistor is controlled by both the vertical and the horizontal deflection circuits in a way that perhaps we'll look at sometime in the future. A little bit of the deflection circuits that make the beam move left and right and make the beam move up and down is sort of sampled through some capacitors and sent to the base of this transistors so that during the retrace time, that transistor is energized. When the beam is at the right-hand edge and has to quickly fly back to the left-hand edge, that transistor is turned on because we don't want to see the horizontal retrace line. When the beam is at the bottom of the screen and it needs to retrace back to the top, we don't want to see those zigzaggy lines. So during that time period, because we don't want to see these vertical retrace lines, as they're called, this also is turned on. So you'll see this. If you look at a schematic, and maybe we'll look at it sometime in the future, there's a little bit of vertical that's sent through a capacitor. There's a little bit of the horizontal that's sent through a capacitor. And basically what the blanking transistor is doing is it's just kind of sniffing that. And during the retrace times, that transistor is energized. Well, clearly that is going to ground the base of all three transistors, right? The base has to have voltage on it or it's not going to turn on. Since the emitter is essentially stuck at 0 volts, we need 7/10 of a volt to turn on those video output transistors to get them to emit electrons. And if the base is, all three bases are grounded through that transistor, the blanking transistor, that can't happen. So again, during the retrace time, when the beam is at the right-hand side and moves back to the left, that blanking transistor is energized. When the beam is at the bottom and has to come back to the top, the blanking transistor is energized. That turns off all three guns during the retrace time. And that's clearly not what's happening in the case of the monitor that Paul or whoever it was, James, has shown us there. Does that make sense to everybody?
Yes, sir.
Yep.
Yep.
Gee, I wonder what happened to our friend from Argentina. Remember a couple of times ago, there was a guy from Argentina that came. I guess it was a little bit too Englishy for him or something. I don't know. So, more questions? Any other questions? Topic of discussion?
Nope. An oscilloscope work block or
Workshop.
workshop would be awesome, though.
You know,
I'm surprised because I was playing with this with John earlier, and this thing was auto working and everything was going well. It just happened to be a time of show. It's gonna give me the trouble, right?
I'm considering, and I'm trying to work on a way to do, not necessarily for the game collectors, but just a basic electronics workshop for kids and people that are interested in electronics that just want to do it. But it was weird because I hopped on Reddit, and there's some electronics message boards on Reddit, and I said, hey, I wrote a little thing, and I said, hey, here's what I want to do, and they went, no thanks. It was like, I don't know, the moderators on Reddit have got some sort of a ego issue or something. I don't know what their problem is. I'm just trying to be helpful. It's not like I'm trying to sell anything. I just thought it'd be fun. You get like, some kid that wants to learn electronics. I'm happy to help him. But so my point, I guess, was the oscilloscope thing would be a cool thing to do for that. So, I have a scope, but I don't actually have a monitor. I suppose I might have to pick up an old CRT monitor somewhere just to show you guys some stuff on it. Don't know.
Not sure where you can find one of those anymore.
Wow.
I'm sorry, conflict. Two people at once. What was that?
I said Randy Fromm without a monitor. That's
Yeah,
sacrilege.
at one point I divested myself of all my electronic junk, which was literally a ton of junk. I mean, I'm not kidding. It took 2 trips for me to get rid of all the stuff. And I just had tons of stuff. And I hate to say, you're going to kill me. I hate to say how many CRT monitors I took to the recycler. But I had been moving them around my life for 20 years. I've been living with these G07s for 20. But I'm not interested in them as things. It was just like just to show somebody how this stuff works. But I'm not a game collector. I'm not a player. Not in any way. I'm just an electronics nerd. So I finally got rid of all that stuff, and now I don't exactly regret it, but now I really kind of need something. And in fact, I've seen a couple of people make these things. I had made a little 9-inch video game. I had made a video game this big with a 9-inch Hunter X MTC 9110 monitor and a Curie Kinton board. Now, I'll bet that's a game you don't even know about. Maybe you do. Remember Curie Kinton? And the only reason I picked that one is it had a board that was only this big. I'm not kidding. It was just like a tiniest little board, and it would fit inside the thing. And I used to take it with me on the road to do a class. I used to, here's a video game. Here's the controls. Here's the joystick and all that stuff. Anyway, sorry, I digress. Does anyone have any more questions about anything that's going on in your life or life, the universe, and anything? Andrew, are you good? Yeah, Andrew.
Sorry.
I have a question if there's time.
And is that Andrew speaking?
That's Andrew speaking.
Speak.
Hanterax NTC 900 chassis. Everybody can scream in horror. Came into my possession. I will turn off my this ridiculous screen background, then you'll be able to actually see the picture. One moment, please.
Alrighty. Yeah, no problem.
When it came to me, the wire that has the little cup on it, is that the anode?
The second anode. Let's call it what it
anode?
is. Yes, second anode.
It was completely disconnected from the flyback. Here, I can hold this up a little better.
From the flyback, not from the CRT, but from the flyback.
From the flyback. So if you can see, there's a spot here. This actually undoes, and the wire was out 100%.
And when you turned it on, did it arc to something?
Oh, I didn't dare turn it on. That's what.
Good. Okay.
Before turning it on, I wanted to check: is it simply a friction fit these days?
Yeah, it just jams together. I guess it's kind of one of the nice things about the high voltage connections is that they do just kind of jam together. Okay. And in fact, it would be bad to try to solder it. There's a weird deal that happens that when you're soldering high voltage, if you leave a tiny little wire sticking out, you get something known as a corona discharge. Corona meaning crown. You get that violet sort of discharge, and you can hear it hissing and smell the ozone. So that's why they do it that way. It's not soldered; it's just jammed together. And yeah, that's fine. I feel sorry for you to have to work on an MTC 900.
The chassis came into my possession. Well, half of it came into my possession. The other half, being the neck board, is still AWOL. And if and when I get it, I found a donor tube which apparently has the right ohms ratings at the yoke that I can try and do this, but I had never seen the wire disconnected like that, so I was a little paranoid before actually powering it up.
It has, as I recall, kind of an odd CRT socket. I can't really recall exactly. It's kind of a weird, as a spline on it, but it's been 40 years, so I don't really recall.
Yeah.
But yes, to answer your question, that's it, Andrew. Algo más? Preguntas más? More questions?
I got a little story about today, this week, if you want to hear it.
Yeah, go ahead, Paul.
I had a customer who sent me in a K7000. He's like, it kept blowing the fuse and it kept smoking. So I was like, okay, send it in. A few days later, this big box shows up at my front door. And my daughter's like, what's in there? I'm like, oh, I'm sure it's a bunch of chassis that need to be repaired. I open it up and he sent the whole monitor. So I was like, man. Luckily, it was only a 13-inch monitor. So I rebuilt the chassis, put it back on. I know I never take full monitors through the mail because most of the time
you mentioned that to me previously. Yeah, I wouldn't either.
So I rebuilt the chassis, put it back on the tube, and immediately it blew the fuse. So it's like, checked everything over. Everything looked good. Stuck a new, actually, I put my circuit breaker on there. And I have like a 4 amp circuit breaker, so I could actually see something smoking. And it turned out that if he didn't send me the monitor, the whole monitor, he would have got back the way he sent it, because the yoke
was a bad yoke.
The yoke started smoking before it tripped the circuit breaker.
Was it the horizontal coil on the inside that smoked? Do you know?
You know what? It was a big puff of smoke coming out of it, so I didn't even check.
Oh, okay.
I just gave him a whole new tube with a new yoke. And so this had a good amount of screen burn on it. So when he got it back, he was very pleased. He was very happy. No screen burn, and it worked great. I had UPS say, I gave it to UPS. I was like, box this up. I don't want to be responsible for it if it breaks. If it breaks, it's on you guys. And they were like, fine. So they super wrapped it and it made it to him.
Would
But-
you mind, Paul, telling us what you might have charged? It's okay if you don't, for the CRT and all the stuff that you did for him.
I think for that, I charged him 150 plus shipping. Because I had all the parts here, and I got so many 13
For
inch.
a new picture tube and a fixed chassis?
Yeah.
He's going to start sending you all sorts of
Wow.
picture tubes now.
Oh, yeah, you're doomed. You're Andrew, you're right. Oh, you're doomed.
What's your
Well,
address? I got a couple I got to send you.
Well, you know,
You know-
James, you can do that. We refer to that as cherry picking. You just go through, you pick the cherries, the low hanging fruit, and you send all the crapola off to people. And that's why I stopped doing that kind of, not exactly contract work, but that kind of work, because I had to adopt a if you've looked at it, I'm not touching it policy. I just had to. It was ridiculous.
You know what? I have the same policy. I'll look at it, but it's not going to be my regular rate. It's going to be my rate plus rate and a half.
At least.
Because if somebody makes a man-made problem, they are horrible to troubleshoot and find, as opposed to a regular failure. It makes
This is true, and in addition to that, the easy ones they fixed. So you're only left with what's we refer to as the tough dogs. You know, the really most difficult ones to fix. So anyway, all right. Well, let's get back on topic here because we have a little time. So anybody else, George? Anybody? I mean, George, you've got a lot of experience. I'm not sure what I could even teach you. Did you have something interesting you wanted to bring up, maybe, or not? You're just
Yeah, actually.
Okay.
I had a couple of Geo7s. So I put together this arcade. It evolved into a barcade but in Niles.
Niles, Illinois.
Yes, sir.
Former home of Wicco.
Wicco,
Niles,
yes.
Illinois. Oh my God! Let's all give a big round of applause to late great Wicco. Oh my God.
Funny aside to that.
Yeah.
The starter in my Space Invaders, it was a Wicco starter for the fluorescent fixture. I kept it just because. But I wanted to talk about these two Geo7s that I had there. I had one where the brightness was like sky high, and it wound up being the electrolytic cap on the neck board that
Absolutely,
10,
yeah, sure.
What was it, a 10160 originally?
Yeah, exactly. Yeah, 250, 10 and 250.
Was it a 250? Okay.
think it was.
Yeah, as you have talked about in the past, necrosis of the caps.
I'm sure I've not used that term, but that's interesting.
You did.
No, I did not.
I think he called it capacitor leprosy.
Capacitor, no, I mentioned capacitor hemorrhoids where the rubber plug sticks out of the bottom.
Yeah, well,
but I don't argue with you, George.
whatever the case, it had like some goo coming out of it,
Yeah,
and then and it was a chassis that I had capped, but for whatever reason I forgot that cap.
Oh,
I don't know how
that's
that
one
happened.
of the big ones. Yeah,
It is, yeah, but there was that one.
And if
where
for
it
no
was like,
just to interrupt you for just 1 second, if for no other reason than it's a flyback derived power supply. And I've mentioned this a couple of times. I just want to reiterate this for those of you folks at home listening, that when a capacitor is working on higher frequencies, in this case 15,750 hertz, the ripple frequency gobbles up capacitors like nothing else. If it's a 60 cycle per second, 60 hertz regular filter cap for a power supply, it'll last a long time. But at 15 kilohertz, it just eats those up, and that's a flyback derived power supply filter capacitor. Sorry, George, go ahead.
and then I had another one where the screen was like super dark. Wound up being the same cap.
Really?
Yeah, isn't that weird?
It's extremely weird. For it to be dark, the voltage would have to be too high. So I just don't understand how a bad capacitor could cause that. And you just simply change what is it, 510 or whatever it is on the neck board?
Yeah, I want to say that chassis I had to recap the whole thing. I hadn't done it yet. And after
and here again is where I I like to do one cap and see what happens, just for knowledge, knowledge purposes. Well, that's very interesting. And again, it comes down to that totally counterintuitive thing where, gee whiz, if the voltage is lower on the cathode, it makes it turn brighter. What the heck is that all about? But that's actually the way it really works, as you know. Any other comments from anybody?
Randy, I'd like to make a comment about capacitors since what was mentioned. If you go to like Mouser and you get, let's say, a 1 UF capacitor, they got several different ratings of capacitors. You can get 1,000 UF capacitor all the way up, 1,000 hour capacitor all the way up to a 10,000 hour capacitor, and they're pretty close to the same price, maybe a penny or two off. You guys hear me?
Yeah, you're kind of cutting in and out, but it's interesting, Paul. It's very interesting that you should mention that, because I was just looking at that yesterday. That's really weird. I was on Mouser and I was looking at their filters and the time and factor and there are various construction techniques. For example, is the rubber plug on the bottom hermetically sealed or not? That kind of thing. I certainly, if you have a chance to you get 105-degree capacitors that are long life, for our purposes, I don't see any reason why you wouldn't do it. I mean, it'd be silly not to.
If you different arcade places sell like the cheap Nichicon caps, and other places sell high Nichicon caps, and the prices are virtually close to the same amount. So if you're going to buy cap kits, do your homework, see what kind of caps they have, and check out the quality. Ask questions.
Yeah, I mean, if it's not Panasonic or Nichicon, I'm not interested. Probably, I will only get 105s, and I don't care what they cost. The parts are cheap. The parts are made out of dirt. You should never ever skimp on parts. You never, especially capacitors. Everything else is more or less the same, but especially capacitors. If you can get Nichicon brand or Panasonic, they're really super high quality, I think.
I've tried to put together a couple of cap kits myself I work on a lot of Sanuels and all that kind of stuff. And I still find it cheaper to buy a fully assembled cap kit than it is for me to buy all the caps out of Mouser or DigiKey or whatever. And I'm not sure if maybe I'm just looking at the wrong ones or whatever, but I always
you're
find
not buying in bulk. You're not buying in bulk. When I buy caps, I buy 100 of each value. Basically, because within 10 years, the life expectancy of the thing, I'm going to use them probably. And if not, I just throw them away. So I did publish on Facebook on the group a list of electrolytic capacitors, and admittedly they have some old part numbers and certainly old prices on them. But basically it's everything from like 1 microfarad to 2200 microfarads, everything from 16 volts to 250. Not big ones at 250, obviously, because you don't need them. But and so then you end up with a big bag of capacitors. I think I've mentioned this story. Hang on, stand by.
The question also becomes, I've just got my own small arcade here. I repair stuff for myself, but not many for others.
Can you see? Is everyone looking at me by any chance?
Yes.
Can you see me if So I probably told this story before that I had this bag here, and this bag is probably 30 years old, 35 years old. I got it at a trade show. There was a company like Wicco that sold parts called JS Sales. And so I have this thing that now I keep these pens in it, but I've always kept parts in here. And I did a repair. Are you seeing me? Because I'm just seeing Pete Cahill.
I can see you.
Okay, good. All right. So anyway, so I had this job in Corpus Christi, Texas, fixing 100 monitors in a week. That was my job. I said, hey, Randy, I'd like to come to Corpus Christi and fix 100 CRT monitors this week. And I went, heck yeah, that'd be really fun. So I got this bag here. Let me just turn this off. And that's fine. Anyway, so I filled this full of electrolytics is the point I'm making. Sorry to digress. So this whole bag completely full of electrolytics, everything in that list from 1 microfarad to a couple of thousand or whatever, was only 350, 400 bucks for that. And so I had everything that I needed. And I'm glad I had done that. You know, on the other hand, if I'm just doing a K7001 and I know I have somebody for $7.95 will sell me a little baggie of all the parts I need, I'm going to do that. And in fact, right now I'm on my back porch. Really, I've got an old pinball machine. I have a 1956 Gottlieb Rainbow pinball on the back porch that somebody wants me to refurbish. But I'm not buying a crap ton of different rubbers. I'm just buying the bag that somebody made up with all the rubbers in it, and you know that's all I need because I'm just doing the one thing. So I understand what you're saying, Paul. It's fine. You know, as long as they're high quality parts. Right. Everybody cool? Any other comments for today?
I
I got another.
Nope.
No, I'll let
Wait,
someone
Paul.
else.
Stand by, Paul. Hang on. Who else speaks? Sorry.
It was Andrew, but I asked my question already, so I'll wait.
Oh, okay. Go ahead. Go ahead, Paul.
This week I worked on a Korean chassis. I've never worked on it before. It kind of looked like they kind of ripped off a 4900
I saw
and a
that.
G07.
Yeah, I saw that
And
picture.
it was amazing the quality they put into it. I mean, it was a nice sturdy chassis, thick traces. It was pretty nice to work on, but I had no information on whatsoever. I had the model number on it, but there was zero information on it on Google. Luckily, it was an easy repair, hot fuse caps, and I got it back up and running. But if I needed any information like specific part numbers, I was out of luck because I couldn't find no information on it whatsoever.
Yeah, a lot of those monitors were made by a company called Seiju, Sejoo, or Cortec. And I went to their factory in South Korea. It was pretty fascinating, really interesting to see how they actually made the monitors there. It was pretty cool. But they made a ton of knockoff stuff, and they were used to make also off-brand monitors. I mean, televisions for consumer products and so on. For example, as you may or may not know, the Wells Gardner K4600 is actually a Montgomery Ward's or a J.C. Penney's television. The board the vertical board that plugs into which we put the RGB and sync, that was actually a different board that was on there. And you can see on the chassis, there's a bunch of non-stuffed parts. There's a bunch of places where you could have stuffed parts, but there are no parts in there. But they were stuffed in those J.C. Penney or Montgomery Ward's TVs. Way back when, if you care. So I think that the thing that you're looking at there, that chassis looked to me to be Seiju to me, but they didn't make enough of them that anybody published a schematic, and they couldn't really publish a schematic because they probably stole that design from somebody else.
Yeah, probably. They did a really good job on it. It was a very high quality board. It was a pleasure working on it. You know, traces didn't lift. There was no cold solder joints on it after 40 years. It was pretty nice.
I'm very pleased with Korean electronics and Korean stuff in general, and it's certainly way better than Chinese. There's no question about it. I mean, it's night and day, as far as I'm concerned. Hey, well, listen, folks. Anybody have anything else? If not, we're just going to call it quits, and I'll post this recording. And any other comments? Anybody at all?
I have a potential topic for the future.
Okay, Andrew.
CRT rejuvenators.
All right.
Have you used them?
Oh yeah.
And recommendations, how to use them. You talked earlier about maybe having a session about using scopes, and it just got me thinking there are other tools perhaps we might include it, and care and feeding of CRT rejuvenators perhaps.
Yeah, Paul, you have two, or three or four or something like that.
Yeah, I got the B&K 467. I got 3 of them.
Oh, the same type though. So, is anybody listening here? Anybody have a Sencor CR70 or CR7000?
Yep. I have a Sencor CR70.
Yeah.
Oh, yeah,
Sencor,
70. Okay.
and I've never used it, so I'm interested in 101 level how to use it.
Pete, do you have the 70 or the 7000?
7000 with the LEDs on it instead of the dial.
Great! How much did you pay for it, Pete?
It was probably about $400 or so.
Okay. That's what I sold mine for when I saw the writing on the wall and CRTs were going away. I went, I don't need this. I'll get rid of it. And I kind of regret that now.
When I picked up my CR70, I bought it for $100 Canadian. I had the opportunity at the same time to buy two CR7000s for $50 each, all working. And I did not know what I was missing.
There it is. Yeah, screw you, James.
Yeah, I know.
Nice, Andrew. Okay.
I've got
Yes.
a
Yeah, let's
hold of
do
a-
that. I don't want to do it now. I really want more than a half an hour for that. But it's a
Yeah.
fantastic subject, and let's do it for next week. So thank you all for coming. I appreciate it very much, and I'll catch you on the flip flop, same time, same station next week.
Thank you very much, Andy.
Appreciate it.
Take care, everyone.
Thanks,
Bye-bye.
Randy.
Stay safe.